So now that we've learned what linked lists actually are, and we've compared them to arrays, which we've used before as well, we've went through some of the pros and cons of using both. We'll now go through some of the functions that we use to be able to access elements in linked lists more easily and add and remove functions and iterate through them. So I'm going to start off with the insert after function. So the insert after function is right here. There are two steps for the insert after function. The first of them is to create a new node that points to the next node after that. So the insert after function is going to create a node in the middle of two other nodes. So say the last node is equal to 30, we'll create the new node that points to that, 30, and then we will make the first node, if the first node equal 10, we would make that node point to the new node as well, so it would be created in the middle. And then we're going to use iterators. So I create an iterator here in the main. This is some of the early code for the linked lists. So this just creates an iterator called iter, and it points to the start of the list, which is here, which is the linked list that we've created. So yeah, the while loop as well, and that will just continue iterating through the linked list until it gets to a null pointer. So the tail of the linked list, the pointer of the tail will always equal to null, so it will go as far as that. So from then we went on to creating the linked list class, which is right here. So we set up some variables here, an mHead and an mTail and a count. So the count obviously keeps count of the amount of items in the linked list, and in the constructor here we set mTail to 0, we set mCount to 0, and we set mHead to 0, which means that is a null linked list, so there's nothing in it at the minute. So that's all the constructor does. Then the destructor, it creates another iterator that points to the head of the linked list, and it creates another variable called next, which the iterator will use to get to the next node in the linked list and delete it, and then go on to the next one until it's equal to null, which is just the end of the linked list again. So the append function, this is the append function here. The append function will add on a node at the end of the linked list. So there's an if and else statement in there, and it will also increment the count whenever you append something at the end of that code. The prepend is the exact opposite of the append. The prepend will add something onto the very start of the linked list, so that will involve having to reset your head, your mHead variable, to the new node. So we'll go on to the remove head function. So the remove head function pretty much just does exactly what it says on the tin. It removes the head of the linked list. So it creates a node, it sets it equal to 0. So then it goes into this if statement here, and if mHead is not equal to 0, the node that we've just created here is equal to mHead mNext, which will be the node after mHead. Then it will delete mHead because you will be on the node after that, and then mHead is equal to node. So you can't delete the mHead if the iterator is on mHead, because then you'll lose the iterator. So and then it just decrements the count as well. So remove tail is again pretty much the exact same as remove head, but it's just a little more difficult. When you remove the tail node, you want to make the tail pointer point to the previous node in the list. But this is a problem because this being a singly linked list, the linked list node doesn't point to the previous node, so you can't get back to the previous node. So we need to, with this code, we need to go the whole way through the entire list and find the previous node. So now we've gone way down here to make the iterator class. So the iterator class has a constructor there as well, and some other functions that we'll get on to. So here's the start function. This just starts the iteration through the linked list from the iterator class. So if the list is not equal to 0, is not equal to null, so that's just checking if there's something in the list, the M node will point to the list's head. The fourth function here, this simply just moves the iterator to the next node in the list. So whenever you call this, it will move the iterator for that list. So again, we have another if statement. If M node is not equal to 0, so if it's not equal to null, then M node is equal to the next node. This is the item function. This is just of type data type, and it's going to return the node's data. So it's going into the node, and then it's just returning the data element within that node. The valid function, this is just a boolean if the node that you're currently on is valid, if it's not null. So it just returns this simple statement here. Now the get iterator function. Because we've created a basic iterator class, we need a way to be able to generate iterators, and this is what this little one-line method is. So this function creates a new iterator pointing to the head of the current list that you're using. So we'll just jump into main here. This is simply using some of these functions, so list.append, and you pass in the data that you want to append to the list, and then this is just printing it out, but it's printing it out with the use of the iterator, obviously. So this is your for and some of the functions that are in the iterator class. So for iter.start, that's just at the start of the iter. Iter.valid, so it will go through the iterator while the node is valid, and this is literally just the equivalent of int I++. This is just continuously going to the next node while it's valid, and it's seeing out the item. So now I'll just go back to the .h, and where are we? We're going to the insert function. Okay, so this is the insert function. It takes in an iterator and a data. So the iterator function, it's the very first line in this is simply checking whether the iterator is equal to is the iterator for this list that you're currently using. The remove function, remove function simply just removes a node at the current iterator. So you call list.remove and you pass in the iterator wherever it is that you want to remove, and again it's checking whether the iterator is for the current list that you're using, and if the iterator .mnode equals 0 or equals null, if it doesn't contain anything, then it will just return out of the function and not do anything more. Here's another one. If p_iterator is equal to mhead, it will move forward and then remove the head. So if you want to, if the iterator is on the head, you can't delete the head without first calling iterator.forth to move away from the head, and then you just call the remove head function. So yeah, we've also gone through some of the pros and cons in the presentation of singly linked lists. The most obvious strength is that you can insert and delete items from a singly linked list quite quickly. But with an array you are forced to move lots of data around to insert an item. Another strength is the ability to expand to indefinite sizes, which, as we discussed in class, it's not indefinite as such. It depends on how much memory you have. And that's pretty much it.